Hello everyone, I'm happy to meet you all once again. Let's start the module 2. I am going to start the module 2 from the topic Uniform Search Strategies. Uniformed search is a category of general purpose search algorithms that employ brute force techniques. Uniformed search algorithms have no additional information about the state. To start the module 2 from the topic Uniform Search Strategies. Uniformed search is a category of general purpose search algorithms that employ brute force techniques. Uniformed search algorithms have no additional information about the state or search space other than how traverse the tree, hence that the term is called blind search. There are various types of uniform search algorithms are there. They are breadth first search, depth first search, depth limited search, iterative deepening depth first search, uniform cast search, bidirectional. Iterative deepening depth first search, uniform cast search, bidirectional search. We will discuss these search algorithms one by one. First, we will see the breadth first search. Breadth first search is the most powerful method for traversing a tree or graph. This algorithm searches a tree or a graph in a breadth first manner. Hence the name is breadth first search. This algorithm searches a tree or a graph in a breadth first manner. Hence the name is breadth first search. This algorithm begins searching at the tree's root node and expands all the successor node at the current level before moving on to the nodes at the next level. The breadth first search algorithm is a general graph search algorithm. The major advantages of this breadth first method are it will provide a solution if one is available. If there are more than one way to solve the problem, then BFS will find the simplest one that needs the fewest steps. This method has some disadvantages. Mainly, it requires substantial amount of memory because each level of the tree must be stored in memory in order to grow to solve needs definitely it requires substantial amount of memory because each level of the tree must be stored in memory in order to grow the next level. Also, it requires a great deal of time if the solution is located far from the root node. The second method is depth first search. Root node. The second method is depth first search. A recursive algorithm called depth first search is used to move through a graph or a tree data structure. The depth first search is so named because it begins at the root node and follows each path to its greatest depth node before proceeding to the next path. DFS is implemented using stack data structure. The same algorithm operates simply to the BFS algorithm. The major advantages of this depth first search is it needs to store a stack of the nodes on the path from the root node to the current node, requiring very little memory. Also, it requires less time to reach the goal node compared to BFS algorithm. Same, we have two major drawbacks of this method. Mainly, it is possible that many states will continue to recur and there is no assurance that a solution will be found. The DFS algorithm search and may sometimes get stuck in a loop that never ends. The third algorithm is depth limited search algorithm. It is an algorithm that resembles a depth first search algorithm with a specified depth limit. Depth limit search can mitigate the drawback of the infinite path in the depth first search. In this algorithm, the depth limited node is treated as if it has no descendants. The depth limited search can be terminated under two failure conditions. The first condition is standard failure condition. It indicates that there is no solution to the problem. Second one is a cutoff failure value that indicates that there is no solution to the problem within a specified depth limit. It has some advantages. Mainly, the memory usage is optimized with the depth limited search. The major disadvantage of this method is incompleteness. Also, it may not be optimal if there are multiple solutions to the problem. The next algorithm is the uniform cast search algorithm. The uniform cast search algorithm traverses a weighted tree or graph. This algorithm is optimized problem. Second one is drawback of the infinite path in the depth first search. In this algorithm, the depth limited node is treated as if it has no descendants. The depth limited search can be terminated under two failure conditions. The first condition is standard failure condition. It indicates that there is no solution to the problem. Second one is a cutoff failure value that indicates that there is no solution to the problem within a specified depth limit. It has some advantages. Mainly, the memory usage is optimized with the depth limited search. The major disadvantage of this method is incompleteness. Also, it may not be optimal if there are multiple solutions to the problem. The next algorithm is the uniform cast search algorithm. The uniform cast search algorithm traverses a weighted tree or graph. This algorithm is implemented when each edge has a unique cast. The primary objective of this uniform cast search is to locate a path to the goal node within the lowest total cast. Uniform cast search broadens nodes in accordance with their path cast from the root. It can be used to solve any graph or a tree in which the optimal cast is required. Implementing a uniform cast search algorithm is a priority queue, means it prioritizes the option with the lowest cumulative cost. The BFS algorithm is equivalent to the uniform cast search if the path cost of all the edges is the same. The major advantage of this uniform cast search algorithm is optimal because the path with the lowest cost is chosen at each state. The major drawback of this method are it degrades the number of steps involved in a search and is solely concerned with the path cost. This may cause the algorithm to become stuck in an infinite loop. The next algorithm is iterative deepening depth first search algorithm. The algorithm for iterative deepening is a combination of both DFS and BFS algorithms. This search algorithm figures out best depth limit by slowly raising it until it reaches the desired path. This algorithm does a depth first search until certain limit is reached. After each iteration, the depth limit is increased until the target node is found. This search algorithm combines the advantages of breadth first and depth first searches. It is helpful to use the iterative search algorithm when the search space is large and the depth of the target node is unknown. The major advantage of this method is it combines the good things about the DFS and BFS search algorithms in terms of how well they use the memory and how quickly they can search. The main problem of this method is we have to do all the work from the previous phase again and again. The last search algorithm is bidirectional search algorithm. Well, the path. This algorithm does a depth first search until certain limit is reached. After each iteration, the depth limit is increased until the target node is found. This search algorithm combines the advantages of breadth first and depth first searches. It is helpful to use the iterative search algorithm when the search space is large and the depth of the target node is unknown. The major advantage of this and the depth of the target node is unknown. The major advantage of this method is it combines the good things about the DFS and BFS search algorithms in terms of how well they use the memory and how quickly they can search. The main problem of this method is we have to do all the work from the previous phase again and again. The last search algorithm is bidirectional search algorithm. The bidirectional search algorithm does two searches at the same time, one from the starting point and another from the goal node, to find the goal node. Bidirectional search replaces a single search graph with two smaller subgraphs, one of which begins the search at the initial vertex and the other at the goal vertex. The search concludes when these two graphs intersect. Bidirectional search technique include BFS, DFS and DLS among others. The major advantages of this method is quick process and uses less memory. The disadvantages of this algorithm are it is difficult to implement the bidirectional search tree and prior knowledge of the desired state is required for the bidirectional search. I hope everyone has enjoyed the session and you got about uniformed search techniques. In the next video, I will teach you the next type of search strategy called informed search. Thank you for watching. Hello everyone, I'm happy to meet you all once again. In this video, I am going to teach you the informed search concepts. An informed search algorithm contains a variety of informations such as the distance from the goal, the path cast, and how to reach the goal node and others. This knowledge allows agents to explore the search space less and locate the target node more efficiently. In a large search space, the informed search algorithm is more beneficial. Heuristic search is another name for the informed search algorithm, as it employs the heuristic concept. In the informed search, there are two primary algorithms. One is best first search algorithm and A-star search algorithm. First, we will see the best first search algorithm. The best first search algorithm always chooses the path that appears to be the best at the present time. It is the combination of the depth first search and breadth first search algorithms. It employs heuristic search and heuristic function. Best first search permits us to take advantage of the benefits of both the algorithms. Best first search allows us to select the most promising node at each step. In this algorithm, the closest node to the target node is expanded and its cost is estimated using a heuristic function. We have a lot of advantages on this algorithm. The primary advantage is the best first search can switch between best first search and depth first search to take the advantages of both of the algorithms. The algorithm is more effective than BFS and DFS. It has some demerits. It may behave as an unguided depth first search in the worst case. So, it can become stuck in the DFS loop so that this algorithm is inefficient in some cases. The second algorithm is A-star search algorithm. A-star search is the most well-known implementation of the best first search. It makes use of the heuristic function and the cost of reaching the node from the starting point. It combines the features of uniform cast search and greedy best first search to efficiently solve the problem. Using the heuristic function, the A-star search algorithm finds the shortest path through the search space. This algorithm expands the search tree less and returns optimal results more quickly. So, the A-star algorithm is similar to uniform cast search algorithm. In the A-star search algorithm, the search heuristics and the cost of reaching the node are employed. Consequently, we can combine both the cost as the fitness number. The major advantages of this A-star algorithm are it is superior to other search algorithms and it is complete and optimal, so we can solve extremely difficult problems by using the A-star search algorithm. Even it has a lot of advantages, the major drawback of this algorithm is it does not always find the shortest route because it relies heavily on heuristics and approximations. So, the A-star search algorithm has few issues with the complexity. The most significant drawback of the A-star search algorithm is its memory requirement, as it retains all generated nodes in the memory, making it impractical for large-scale problems. I hope everyone has enjoyed the session and you got the information about informed search techniques. In the next video, I will teach you the adversarial search concepts. Thank you for listening. Hello everyone, in this session we are going to see about adversarial search. Adversarial search is a search in which we investigate the problem that arises when we attempt to plan ahead of the world while other agents are also planning. In previous sessions, we discussed the search agents are also planning. In previous sessions, we discussed the search strategies that are only associated with a single agent seeking the solution, which is frequently expressed as a series of actions. However, there may be instances in which more than one agent is searching for the solution in the same search space. This typically occurs during gameplay. The environment containing multiple agents is known as multi-agent environment, in which each agent is an opponent of the others and competes with them. Each agent must consider the effect of another agent's action on their own performance. Therefore, searches in which two or more players with competing objectives attempt to explore the same search space for a solution are referred to as adversarial searches. Games are modeled as a search problem and a heuristic evaluation function, and these are the two important factors for modeling and solving the games in artificial intelligence. There are four types of games in the artificial intelligence: perfect information games, imperfect information games, deterministic games, and non-deterministic games. have access to all game information and can see each other's moves. For example, chess, checkers, Go are some of the games for the perfect information games. The second one is imperfect information games. If in a game, agents do not have complete information about the game and are unaware of what is happening, is referred to as imperfect information games, such as tic-tac-toe games, battleship game, blind game, bridge game, and etc. The third one is deterministic games. There is no randomness associated with the deterministic games, as they adhere to a strict pattern and set of rules like chess, checkers, and etc. The last one is non-deterministic games. Non-deterministic games are those with unpredictable outcomes and the factor of chance or luck. This element of chance or luck is introduced by dice or playing cards. These are random and actions are responses and are not predetermined. These are also referred to as stochastic games. The examples for non-deterministic games are backgammon game, monopoly, poker, and etc. Games referred to as stochastic games. The examples for non-deterministic games are backgammon game, monopoly, poker, and etc. A game is a type of AI search that can be formalized with the five major components. The first one is initial state. It indicates how the game is initially set up. The second one is players. It indicates which player has moved within the state space. The third one is the game is initially set up. The second one is players. It indicates which player has moved within the state space. The third one is the action. It returns the collection of legal moves in state space. Fourth one is the result. This is the transition model which specifies the outcome of the state space transitions. The last one is terminal test. A terminal test returns true if the game is over. Otherwise, it returns false. The terminal states are the states in which the games end. The next one is the game tree. A game tree is a tree in which the nodes represent game states and the edges represent player moves. The game tree consists of an initial state and in which the next one is the game tree. A game tree is a tree in which the nodes represent game states and the edges represent player moves. The game tree consists of an initial state, an action function, and a result function. It consists of of an initial state, an action function, and a result function. Example, tic-tac-toe game tree. This diagram depicts a portion of the game tree for the tic-tac-toe game. There must be some important aspects of the game, like there should be 2 players, maximum, minimum, and a present. Players should take turn alternatively, beginning from max. The max optimizes the game tree's outcome, and the max reduces the output. From the starting point, max has 9 possible actions, and both players play alternatively until a leaf node is reached in which one player has 3 in a row or all squares are filled. Both players will compute each node's mini-max value, which represent the best possible utility against an optimal opponent. Assume both possible utility against an optimal opponent. Assume both players are familiar with the tic-tac-toe game and are employing the optimal strategy. Each player is attempting to prevent the other from winning. In this game, minimum is the competing against maximum. Therefore, the game tree contains a maximum layer, minimum layer, and a player layer for each. This game continues until a terminal node with the maximum placing X and the minimum placing 0 to prevent maximum from winning. Either minimum or maximum wins or results is draw. This game tree represents the entire search space of possibilities in which maximum and minimum alternatively play tic-tac-toe and takes the turn. Consequently, adversarial search for the mini-max is conducted as it seeks to identify the optimal winning strategy of maximum. The method utilized is depth-first search. The optimal leaf node in the game tree could appear at any depth. We have to distribute the minimax values. Up to the tree until the terminal node is identified. I hope you understand about the adversarial search. In next video, I will teach you the local search algorithms. Thank you for watching. Hello everyone. In this session, we are going to see about local search algorithms. When we are simply interested in a solution and not the route to the solution, local search techniques are applied. In the majority of AI, going to see about local search algorithms. When we are simply interested in a solution and not the route to the solution, local search techniques are applied. In the majority of AI models, local search is utilized to look for the best answer given the model's cast function. This model is used for clustering, neural networks, and linear regression. To discover the peak of the mountain, networks and this model is used for clustering, neural networks, and linear regression. To discover the peak of the mountain or the best linear regression. To discover the peak of the mountain or the best solution to the problem, increasing elevation has a linear regression. It is used for clustering, neural networks, and linear regression. To discover the peak of the mountain or the best solution to the problem, the hill climbing algorithm continuously progresses in the direction of increasing elevation or the value. When it reaches a peak value where none of its neighbors has a greater value, then it ends. The hill climbing algorithm is a method for solving mathematical optimization issues. The traveling salesman problem, in which we must reduce the salesman's journey distance, is one of the best to choose. The traveling method for greater value, then it ends. The hill climbing algorithm is a method for solving in the direction of increasing elevation or the value. When it reaches a peak value where none of its neighbors has a greater value, then it ends. The hill climbing algorithm is a method for solving mathematical optimization issues, the traveling salesman problem, in which we must reduce the salesman's journey distance, is one of the best known applications of hill climbing algorithm because it only searches within its good neighbor state and not further afield. It also known as greedy local search. The two parts of a hill climbing algorithm node are the status and values. When a reliable heuristic is available, hill climbing is typically used. Since this algorithm just retains a single current state, we don't need to manage or maintain the search tree or a graph. There are three major features of hill climbing search: generate and test variant, a greedy approach, no backtracking. Hill climbing is a generate and test method variant. The input generated by the generate and test approach aids in choosing which way to move the search space. Similarly, a hill climbing algorithm searches in a direction that minimizes the cost as a greedy approach. Also, since it cannot recall their prior states, it does not go back in the search space is called no backtracking. The hill climbing algorithm is graphically represented by the state space landscape, which displays a relationship between different algorithmic states and objective function or cost. The state space on the x-axis and the function, which can be either an objective function or a cost function, is on the y-axis. Finding the global minimum and local minimum is the aim of the search if the y-axis function is cost. Finding the global maximum and local maximum is the aim of the search if the y-axis function is an objective function. There are four major parameters we need to find with the hill climbing algorithm. Objective function on the y-axis in different greedy approach. Go by the graph search space is called no backtracking. The hill climbing algorithm is graphically represented by the state space landscape, which displays a relationship between different algorithmic states and objective function or cost. The state space on the x-axis and the function, which can be either an objective function or a cost function, is on the y-axis. Finding the global minimum and local minimum is the aim of the search if the y-axis function is cost. Finding the global maximum and local maximum is the aim of the search if the y-axis function is an objective function. There are four major parameters we need to find with the hill climbing algorithm: local maximum, global maximum, current state, flat local maximum. A local maximum state is the one that outperforms its neighboring states while also being outperformed by another state. The second one, global maximum. being outperformed by another state. The second one, global maximum. The ideal state for the state space landscape is known as the global maximum. The value of its goal function is at the highest. The third, the value of its goal function is at the highest. The third one is the current state. It is a state in a landscape diagram where an agent is currently present. The last one is flat local maximum. It is a flat space in the landscape where all the neighboring states of the current state have the same value. There are three major types of hill climbing: simple hill climbing, steepest ascent hill climbing, stochastic hill climbing. In simple hill climbing is the most basic method for putting a hill climbing algorithm into action. Only one neighbor node state is evaluated at a time, and the first one that minimizes the current cost is chosen and set as the current state. It only examines one successor state, and if it discovers that it's superior to the current condition, it moves to that state that stays there. These characteristics of this algorithm include: it takes less time, and lesser optimal solution exists, and solutions are not guaranteed. The second type is steepest ascent hill climbing. A variant of straightforward hill climbing algorithm is the steepest ascent algorithm. This method looks at every node that borders the current state and chooses the one that is the most near to the goal state. This algorithm takes longer since it looks for more neighbors. The last type is stochastic hill climbing. Before moving, stochastic hill climbing does not look longer that is the most near to the goal state. This algorithm takes longer since it looks for more neighbors. The last type is stochastic hill climbing. Before moving, stochastic hill climbing does not look for all of its neighbors. Instead, this search algorithm randomly chooses one neighbor node, then decides whether to use that node as a current state or look at a different state. I hope you understand about local search algorithm, hill climbing, its features and the types. In next video, I will teach you the knowledge representation. Thank you for watching. Hello everyone. In this session, we are going to see about knowledge representation. Humans improve at understanding, logical reasoning, and knowledge interpretation. Human possesses knowledge which they use to accomplish a variety of acts in the real world. However, knowledge representation and reasoning deals with how machines carry out all these tasks. As a result, the knowledge representation can be defined as it is an area of artificial intelligence that deals with how thinking affects an agent's ability to act intelligently. It is in charge of presenting information about the real world in a way that computer can comprehend it and use it to solve complicated problems in the real world, such as diagnosing medical condition or interacting with people in natural language. It is also explains how knowledge can be represented in artificial intelligence. Knowledge representation allows an intelligent computer to learn from its knowledge and experiences so that it may behave intelligently like a human rather than just storing a data in the database. There are 6 kinds of knowledge which needs to be represented in AI system. They are objects, events, performance, meta-knowledge, facts, and knowledge base. Objects are the information on every object on our planet. For instance, drums are brass instruments, whereas guitars having strings. Events are the things that happen in our world. Performance refers to actions that require knowledge of how to be done. Meta-knowledge is the knowledge of our own knowledge. Facts are actually world, truth, and what we stand for. The knowledge base is the core element of knowledge-based agents. It indicated as knowledge base. There are 5 different types of knowledge: declarative knowledge, heuristic knowledge, meta knowledge, procedural knowledge, and structural knowledge. In the procedural knowledge, and structural knowledge. In declarative knowledge, it is the knowledge is know about something. It includes concepts, facts, and objects. It is also called descriptive knowledge and expressed in declarative sentences. It is simpler than procedural language. The second one is procedural language. It is also known as imperative knowledge. The procedural knowledge is a type of knowledge which is responsible for knowing how to do something. It can be directly applied to any task. The procedural language also includes knowledge and structural knowledge. In declarative knowledge, it is the knowledge is know about something. It includes concepts, facts, and objects. It is also called descriptive knowledge and expressed in declarative sentences. It is simpler than procedural language. The second one is procedural language. It is also known as imperative knowledge. The procedural knowledge is a type of knowledge which is responsible for knowing how to do something. It can be directly applied to. The procedural knowledge is a type of knowledge which is responsible for procedural language. It is also known as imperative knowledge. The procedural knowledge is a type of knowledge which is responsible for knowing how to do something. It can be directly applied to any task. It includes rules, strategies, procedures, agendas, and etc. The procedural knowledge depends on the task on which it can be applied. The third one is meta-knowledge. The knowledge about other types of knowledge is called as meta-knowledge. The next one is the heuristic knowledge. Heuristic knowledge is representing knowledge of some experts in a field or subject. Heuristic knowledge is rules of thumb based on previous experiences, awareness of approaches, and which are good to work but not guaranteed. The last one is structural knowledge. The structural knowledge is the basic knowledge to problem solving. It describes the relationship between various concepts such as kind of, part of, and grouping of something. Then we will discuss. It describes the relationship between various concepts such as kind of, part of, and grouping of something. Then we will discuss about the relationship between something. Then we will discuss about the relationship between knowledge and intelligence. It describes the relationship between ideas or objects. It describes the relationship between ideas or objects. Real-world experience is essential in ideas or objects. And intelligence. It describes the relationship between ideas or objects. Real-world experience is essential for intelligence, just as it is for development of artificial intelligence. When it comes to AI bots acting intelligently, knowledge is crucial. Only when an agent has some information or expertise regarding an input will be able to respond it to appropriately. Consider what you would do if you were confronted with someone speaking a language you didn't understand. The agent's intelligent conduct falls within this same area. As shown in this diagram, one decision maker uses knowledge and environmental sensing to act, but it cannot behave intelligently if the knowledge component is absent. AI knowledge cycle and AI system has the following major components like perception, learning, knowledge representation and reasoning, planning and execution. As per the diagram, how an agent system can interact with outside environment and what elements enable it to demonstrate the intelligence. The perception component of an artificial intelligence system allows it to gather the data about its surroundings. Visual, rural, or other sensory inputs are all acceptable. The learning component is in charge of learning from the information that the perception behavior has collected. Knowledge representation and reasoning are the key elements of the entire cycle. These two elements have a role in demonstrating the intelligence of human beings who resemble machines. These two elements are connected yet also operate independently of one another. Analysis of knowledge representation and reasoning is required for both planning and execution. I hope you understand about knowledge representation and its types. In next video, I will teach you proportion and first order logic. Thank you for watching. Hello everyone. In this session, we are going to see about proportion logic and first order logic. The simplest type of logic is called proportional logic, in which all claims are made using propositions. Whether true or untrue, a proposition is a declarative assertion. It is a method for logically and mathematically representing knowledge. Few examples of proportion logic are: it is a Sunday is a true proposition. 5 is a prime number is also a true proposition. The sun rises from west is a false proposition. 3 plus 3 is equal to 7 is a false proposition. There are few basic facts about the proportional logic. Boolean logic, which operates 0 and 1, is another name for proportional logic. In proportional logic, symbolic variables are used to represent the logic. Any symbol such as A, B, C, P, Q, R can be used to represent a proposition. A statement can only be true or untrue. It cannot be both. Logical connectives, relations, and objects make up the proportional logic. Logical operators are another name for these connectives. The fundamental building blocks of proportional logic are propositions and connectives. Connectives are proportional logic are propositions and connectives. Connectives are logical operators that link two sentences together. A valid sentence is also known as tautology, which is a proposition formula that is always true. A proposition formula is referred to as having both true and false values. Questions, orders, and statements expressing the opinions such as "Where is Rohini?" "How are you?" and "What is your name?" are not considered as propositions. The acceptable sentences for the knowledge representation are defined by the syntax of the proportional logic. There are two different kinds of propositions: atomic propositions and compound propositions. Atomic propositions are the most basic types of statements. There is only one proposition sign in it. These are the statements that can only be true or untrue. Utilizing the parentheses and logic connectivities, compound propositions are created by merging simpler or atomic assertions. Next, we will look at the statements that can only be true or untrue. Utilizing the parentheses and logic connectivities, compound propositions are created by merging simpler or atomic assertions. Next, we will see about the first order logic. We learned how to represent statements using proposition logic in our study of all the subject. But sadly, with the proportional logic, we are limited to representing only the facts, which can either be true or untrue. Complex sentences or statements in natural language cannot be adequately represented using proportional logic. Proportional logic expressive ability is quite constrained. If we use the proportional logic, we cannot represent the following sentences like "some humans are intelligent" or "Sachin likes cricket." First order logic was needed since propositional logic is insufficient to represent the aforementioned statements. There are few facts about the first order logic. First order logic is yet another method used in the artificial intelligence to describe the knowledge. A development of propositional logic is the first order logic expressive enough to accurately describe the natural language statements. The first order predicate logic and predicate logic are the other names for the first order logic. First order logic is a potent language that expresses the link between the items as well as how information about the objects can be developed more easily. First order logic makes some assumptions about universe in addition to the fact that it contains the facts as thus propositional logic, like object, relationship and functions. Objects are like A, B, individuals, figures, numbers, hues, conflicts, theories, squares, pits and vampires and etc. Relationship might be unary like a red or round or nearby, or they can be n like figures, numbers, vampires, round or nearby, or they can be n like the sister of, like the brother of, has the color, or comes between, like that. Functions include father, best friend, third inning, finishing and etc. I hope you got the points about first order logic and propositional logic. By this, the module 2 has over. Thank you for watching. Hello everyone, I welcome you all for the practical session. In this session, we are going to study about Prolog. Prolog, which stands for Programming in Logic, is a declarative programming language best suited for logical inference and reasoning. Unlike standard programming languages, users ask questions rather than run a program to get the solution in Prolog. Prolog is not used for implementing numerical algorithms. Instead, it is used for symbolic and non-numeric computations. Prolog was developed in the year 1970 by Alain, along with his colleague at the University of Aix in France, and was initially used for natural language processing tasks. The language gained popularity in 1980 his colleague at the University of Aix in France, and was initially used for natural language processing tasks. The language gained popularity in 1980s and 1990s, when it was used for a wide range of applications, including expert systems, natural language processing, robotics, and database programming. In the 1990s, Prolog community began to develop new extensions to the language, including constraint logic programming, which allowed for the specifications of complex constraints on variable and object-oriented Prolog, which added support for object-oriented programming. Today, Prolog is still widely used in research and development in artificial intelligence and expert systems, as well as in applications such as natural language processing, database programming, and robotics. Its use has also expanded to new areas such as machine learning and computer vision. Prolog programs consist of a set of logical statements or classes, which can be queried to derive new logical conclusions. Prolog uses a form of logic called Han class logic, which also allows for efficient reasoning about large sets of data. Prolog has a number of important features that make it well suited for certain types of programming tasks. For example, it provides built-in support for backtracking, which allows the programmer to explore multiple possible solutions to the problem. Prolog also supports pattern matching, which allows for efficient manipulation for complex data structures. Prolog is a powerful tool for tasks that involve logical inference and reasoning, and it has found widespread use in applications such as expert system, natural language processing, artificial intelligence, and database programming. Let's see how to install the Prolog programming. See the link. From this, we can download the package and we can start install. You can give next in this option, run the GNU Prolog setup file. Then it will ask the destination location, then give next, then the installation process will be go on. So after completing the installation, you could use the Prolog programming. I hope now you got about why we are using this Prolog programming. In next video, we'll see about facts, variables, characters, constants which are going to be used in the Prolog programming. Thank you for watching.